Hi, I'm Bill from Solidigm, and I'm here at HPC24, and who do I have the pleasure of speaking with?
My name is Rich Vudak. I'm a professor in the School of Computational Science and Engineering at Georgia Tech.
At Georgia Tech, okay, so we know Georgia Tech has some pretty outstanding research capabilities. Can you tell me what is really the scope of focus as it pertains to HPC at GT?
I think it's really in the area of accelerating science and engineering applications. So we really want HPC to be an enabler for the next great discovery in science or the next great invention in engineering.
Okay.
So and we're also expanding into the spheres of social and public policy, urban sustainability, and lots of pressing problems of the day.
Interesting. Okay. How does Georgia Tech build out its infrastructure to necessarily support, these research divisions and these organizations that are outside the university?
Yeah. Well, we're trying to increase our presence in the national infrastructures, primarily those supported by the National Science Foundation. So we have maybe two examples come to mind. We recently had a major research instrumentation grant or project to acquire some hardware that is available to scientists and engineers throughout NSF's network.
I see, okay.
And we also have created another NSF supported test bed for experimental hardware. And what we're trying to do with both these resources is, of course, provide the hardware itself, but also expertise, system administration, maintenance, just to do, make it easier for users and the community to make use of them.
Got it. Okay, great. Well, how do you think the HPC changed? Kind of with the advent of AI, and how has this necessarily changed and some of the support infrastructure, compute infrastructure you have?
That's a great question. It's had, two very dramatic impacts. I think the first is it's impossible to escape GPU processing.
Right.
And so we're obviously needing to make major investments in anything that is sort of GPU-like.
Right.
And I think it also poses challenges for storage, both storage of our own data, like researcher data, but there's also kind of stressors on the storage system itself, because the nature of data, streaming data in and out, is different under AI workloads than it has been under classical kind of scientific simulation workloads.
I see. Do you think, kind of with that theme, with the element of storage, do you think the abundance of having, say, high-capacity storage is beneficial? In that
absolutely. High-capacity storage is definitely a must.
Okay.
I think support for kind of smaller transactions as opposed to large transactions, that's another kind of new stress area.
Interesting. Okay.
Yeah. So that's something we see. It was also something highlighted by Meta in one of their talks here at the conference.
Oh, okay. Well, tell us about some of the key research that you're kind of calling out here at SC24.
We have a mix of research projects. One near and dear to my heart is I have a couple students, actually one who just won the second place in the ACM student research competition.
Okay.
And that is and then I have another student presenting a paper on Thursday, later this afternoon.
Yeah.
Both of those are in the area of graph analytics. So I think this is an extremely important workload that's kind of traditionally underserved by the kinds of systems, both on compute and maybe in storage and memory, than we've seen in the past.
I see. Okay. Well, it sounds like maybe some of these research pieces that you kind of talked about, maybe some of them could be fairly data intensive.
Yeah.
How does then data management then allow you to integrate and maybe to expand capacity at scale, say for instance?
Yeah, because they're data intensive, you need good ways to organize things. You need good ways to query and access. These are classical problems in database systems, but the kinds of, I think, queries and analytics people want to do on graph data sets has a different character. I foresee a lot of potential stressors as we try to scale up some of these examples.
Right. Okay, great. Well, finally, hey, maybe you can kind of tell the folks where they can get more information on Georgia Tech and some of the interesting work that you guys are doing.
Yeah, definitely. Hit our website, www.gatech.edu. That's, I think, the place to start. And then, of course, use your favorite search engine to look for high-performance computing at Georgia Tech, and you'll hit tons of resources. So.
Great. Awesome. Well, hey, thanks for joining us.
Yeah, thank you.
Appreciate it.
Great to meet you.